Hello! Nobody listens to these internet things anyways, but anyways, welcome to Calculus in the PM. I'm Mr. Shindel. I guess I'll plug it in so you guys can see what I can see. Onto the board. So we're on that derivative of a to the x page, eh? I think it's your third last page. I don't know if I inserted, it might be page 8 or 9 on yours. It's actually, is that the second last page for you guys?
Page 9, yes.
Okay, so that's my page 10. Oh, I'm on page 10. I see. Yeah. Got it. Because I inserted a page when I did some work. That's why. Okay. Now, before this, I should mention, by the way, this whole section, there's nothing in this section, 4.4, that isn't in regular calculus. Logs, logarithmics, functions, and exponential functions. So, this isn't, the only section really is the inverses that is extra, just so you know. Derivatives of a to the x. Now, I want to go backwards in time here a little bit. We remembered this. Natural logs, they're pretty easy to do actually, comparatively. And the e to the x stuff is pretty easy to do, isn't it? Derivative of e to the x is itself, right? E to the x. Depends if you have something in that exponent. But if the base isn't e, so if it's 2 to the x or something like this, there's a little formula you got to use and all that kind of thing, right? Now, you don't have to memorize this formula. A couple reasons why. It doesn't come up that often. I don't think anybody said it was in last year's test. It doesn't. It could. It can. But if you know how to find the derivative of the natural log of x and everything there, you can come up with that formula pretty darn fast too. So, because I don't like people memorizing too much, you'll memorize the natural log, how that works, right? So let's just see here. What if you called this, and this is why I'm saying you don't have to memorize this formula. So what if you got y equals, we'll use a to the u, but it could be 2 to the x squared or something like that. So we'll go with a to the u right now. That's it. How do you do the derivative of this? You don't have a rule right now. How do you come up with this rule is what I'm asking. So don't use this rule because that's just rewriting the rule then, right? Basically, remember, u is something with x's in it. And you're going to say something. Well, how do you get that u down? Because if you have your x's in there and it's like 2 to the x, etc. So I'm going to put this as an example over here. Y equals 2 to the x. We'll just keep it simple. Or maybe you want 2 to the 3x? We'll go with that. A little, ramp it up a bit. This is the same problem, right? How do you get that x downtown? Like, so that you can play around with it. How do you get, if you take a log, let's take a log of both sides. And this is a technique you might not occur to you, and that's why I'm showing you. Take the log of both sides. I'll do the blue stuff first, and then we'll do the red. So the natural log of y equals the natural log of this a to the u expression. This is why I don't memorize this formula. I really don't. I usually work it out in the margin if I need it. So then what? I still need to get that u expression. U is a function of x, right? X squared plus 5 or something like that in there. So how do I get u out of the exponent? This is a log expression, right? So what do we do?
U natural log.
Yes. You can bring the u down. You think of it as multiplied. Because exponents on exponents. Hey. Isn't that the other day we went over this? Yeah. Like I know you guys don't remember this. So then, yeah, it comes out the exponent right there. And we showed that, right? This kind of stuff here. That's what we're talking about, right? Okay. So then, once you get familiar with these rules, the left side doesn't change. The natural log of y is equal to the natural log, or u, the function of x, natural log of a. A is a number, 5, 2, e, whatever. Well, it wouldn't be e because you could just do it for it. Anyways. Then what? I think it's time to do a derivative. Sure. Okay. Good. Now, I'm going to just insert, like, you know, okay, I wouldn't write this out, is what I'm saying. But I'm going to just to show you what I'm doing. I'm thinking this. What's the derivative of the left side? It's going to have a dy by dx, yeah, because it's a mismatch. But what about the natural log part? You did the inside first. It's just 1 over y, 1 over whatever you got. So it's 1 over y dy by dx. I'm running out of space here. Thought I had light years of space. But I don't. There we go. The right side now is equal to natural log a is a constant. It's a number. So think of this as the derivative of 5u, or 7u, or 7x. What would it be if I said
0, technically.
7x?
Plus.
So what I'm saying is that u is a variable. It might be an expression like x squared plus 5.
Oh,
Right?
du over dx.
Just wait. If this was, and I'll erase this out, think of the natural log of a as the natural log of 2. It's some decimal number, right? I don't know what it is. So if it was 0.693 is the natural log, or like, of that number, times u, what is the derivative of that? Tell me.
693.
0.693.
Or no.
Yeah, it is. It's the number. Du by dx because it's a mismatch, right? You guys follow this? It's no different than saying what's the derivative of 5u? It's 5. 5x, it's 5. Except that it's not an x, it's a u, so we have to have du by dx, right? Meaning you have to take care of the inside of that. Now I know this is confusing at first. By the way, if you type in ln2, it'll be 0.693. That's what it says. ln of a, natural log of that number, whatever the base is. But it's a mismatch, so du by dx means the derivative of whatever's inside that thing. Okay. To isolate for dy by dx, what we want to find, right? We've got to just multiply this u onto that, or sorry, this y onto that side, correct? But what is y?
No, it's a
That's au, a to the u, right? So when I multiply it up, and I'm only doing this because I'm running out of space, I would show it as 2 steps otherwise with you guys. So this y I'm multiplying onto the other side, but instead of writing y, natural log of a, I'm going to substitute right now as, I'll actually, yeah, a to the u, natural log of a du by dx. Yeah, the product rule. No, because this is a constant. This is a number. That's what I was trying to get across to you guys when I had that decimal 693 stuff, right? It's just a number. Even if you don't know what it is, it's still a number, right? Just like the cosine of 30 degrees is a number. Right? Now, what I just went through is, this is the formula. Like, these formulas aren't witchcraft, right? Hope I got it right, yeah. Nope, they're not. Okay. So, I want to see from first principles. I don't even have to memorize that formula. I actually just do these the same way. let's quickly do this. And I'm going to do it without the formula. I'm going to do it from first principles like this. So, if I ask you to take the derivative, I move this around too much, I can just make it some space here. 3x is the exponent, right? What's the first thing you should do to get that 3x out of the exponent?
Natural log.
Both sides, natural log. So the natural log of y equals the natural log of 2. And I'm already, I left a space there because I could see, oh, 3x, why would I write it up there? I think the whole point is to get it down, so I erase it right away, put it down, oh yeah, 3x. See that? Then,
Do you want brackets?
do you need brackets? If it makes you feel good, do it. You're saying this, right? If it helps you recognize that's a number, go ahead. Like, that's not, I think of it as 3x times, so it's legal to not use brackets in that case. There's no addition or subtraction. Now I'm ready to take the derivative of the left and the right side. The derivative of the left side is 1 over y.
1 over y,
Yep. Derivative of the right side? Well, the derivative of natural log of 2 is a number, so natural log of 2 times 3. 3 is the 3x part, right? 3 times the natural log of 2. If it, even though we wouldn't write it this way, you might want to think of it this way. 3 natural log, have all your numbers in front of the x. If that helps you, whether you literally write it down that way, that's great. This in brackets is a number. So I'm just saying you could think this. But typically you will see such an expression written out like this. That's it. Just get used to seeing the numbers times the x, whether you write it down in that order or not. That's the same thing. So, as Miles said, x to the 1, it's just 1 now. So 3 natural log of 2. Okay, I can isolate for dy by dx, but what does y in this case stand for?
2 to the 3x.
2 to the 3x. So when I multiply the y to the right-hand side, oh, look at that. dy by dx, I reckon 3 natural log of 2 times 2 to the 3x. I only use the brackets to separate. To emphasize that power of 3x only applies to the number 2 right there. You can't simplify this by saying, well, 3 times 2 is 6. Wrong. That's adulterous. Don't do that. Rubbish. You guys know this, right? 2 times 10 to the 5 is not 20 to the 5, right? Okay? It's a mistake that I hope I won't see, but I have seen. If you were to just apply this formula to this, just think about this. Okay, a to the u. So in this case, it'd be 2 to the 3x, right? Natural log of 2, okay, 2 to the 3x, natural log of 2, plus the derivative of the exponent. What's the derivative of the exponent? I said plus, though, times the derivative of the exponent, 3. It's all there, isn't it? However, like I've said, if you try to memorize a bunch of formulas, good. If you're good at memorizing things and at the end of the year you got them all memorized, that's great. You don't have to. It's only really a few steps because it's not worth littering your mind with too many formulas. Some people will memorize it, and that's fine. At what point on the graph of y equals 3 to the x plus 1 is the tangent line parallel to 5x minus 1? Well, how would I do this? Derivative of the expression gives you a slope formula. over tangent line. What do we want the slope to equal? Can we see that right away? Yeah. So the easy part is we want slope equal to 5 because it's parallel. Okay. We're doing the derivative of the 3x plus 1 expression. Guess what? We're going to do the formula window this time. Okay? This expression's derivative is what we're doing, right? I'll use green. So y is equal to 3 to the power of x plus 1. Now the 1's going to zero out when I do the derivative. It's really the derivative of 3 to the x. Let's apply this formula though. dy by dx, because it's fresh in my head, I just did it. The a to the u part is just rewrite it, right? 3 to the x. The natural log of the base, natural log of 3.
Did you forget 1 over y though? On the left?
No, I'm just applying the formula.
Oh,
Like, if you know you got 5 or 6 of these things to do, I would take my time to do the formula. Like if you're in a test at the university or something like this and you know that you have a lot to do, write out the formula, right? And do it for this section. But I'm saying in May, in April, you might not have the capacity to remember 17 different extra formulas when you can work them out. So we're using this formula directly. So this is the a to the u part, this is the natural log part. Now the derivative of the exponent, of the inside, the inner function, is just 1, right? I'm not going to write down times 1. Yay or nay? I went really fast through some of this. Okay, so I've got a derivative, so I've got a function that gives me the slope of the tangent line. I've got a slope for the tangent line, it's 5. So what do I do next?
sub in 5 for x.
Yep. 5 is equal to 3 to the x, natural log of 3. Natural log of 3 is just a plain old number, so we need to isolate, don't we? So, first thing is get the function with the x alone. This is the function with the x, so we're going to divide both sides by natural log of 3. Right? That's going to disappear. I'm going to just stick to one color now. 5. Where am I? Natural log of 3 is equal to 3 to the x. Am I good on this? How do I escape that x? How do I solve for x? Do the logs. Yeah, on both sides. Natural log of both sides, right? Now this is just a number, the 5 over natural log of 3. So the natural log of 5 over the natural log of 3. Natural log of 3 to the x. Hey, why would I write that down? What should I write down instead? X. Oh, I thought I had it separated. I did. This board detaches things too quickly. I'll set the pen down for a second. Right? I'm using that, and I try to get used to that right away as you step. Now I can solve. Now that's a mess, but it's something your calculator can handle. But if it was a non-calculator question, you'd just say x is equal to natural log of 5, natural log of 3. Exactly like that. I want to see though, can you guys enter that into your calculator? Yep, you can. I'm waiting for you. Get it to 3 decimal places accuracy. Just to make sure we enter things correctly. Make sure you use brackets around this part of the expression for sure, right? The numerator. You guys got a value yet?
I have one
Yeah.
decimal 421.
No.
No?
One decimal though. You got that part.
Decimal 379.
Hey, she's a winner. Now, it must be an entry error, obviously, unless you're on like hexagesimal setting or hexadecimal or whatever they call it.
This is an algorithm.
Yeah,
Why does it have to be a natural log and why can't it be like a log base 10?
you can have a log base 10, you'll get the same answer.
Doesn't matter at all.
However, stick to natural logs because if you ever have to do calculus on things, it's easier. The other fact is that this part is not negotiable. This is a natural log of 3. But this step you could have done LOG. LOG, that's fine too. That step. Okay. And you'd still get the 1.379. Hey, all that work and you usually quit because you think you've done the problem because it's too much work. Nope, there's a reason why I left the right-hand side. At what point on the graph is this tangent line parallel to it? I've got x equals, a point is x and y, it's an ordered pair. So, how do I find my y value? What's that? Plug it in, which equation?
The original.
Yeah, which is the original? I got two y equals equations. 3x1. Okay, yeah, use your calculator there. Good. So then you can create this as y of x if you want. I like doing that just so I know what I'm plugging in. Yes, 3 to the 1 point. And then you get that. I'll tell you what that one is. 5.549. 9. So, it's parallel at the point 1.379, 5.549. And I'll talk to you about when I need sentences and explanations as it comes up. This kind of problem, if you've clearly, at what point, it says at what point. I don't need a description. That's me, though. Wow. So that's how you do it when you got 7 to the power of 3x, or 10 to the power of 12x squared plus 1. Next, one more page of little goodies. What if you got logs like log base 10, log base 2? Once again, you don't have to memorize, but you'd have to know the base change formula, and nowadays, I don't think you guys know the base change formula that well. You can work these out though anyways, from first principles. I'm not going to go through that though. We'll apply the formula. If you want to though, I could sit down with you how the base change formula works. It's not that much, because it's based on the natural log stuff again. By the way, just going back, for a final exam in Math 111 and stuff like this, I did have, I think it was math, I don't know. I have memorized this, but I always, the thing is like 20 years later or something like this, how do you remember this? I do remember somehow the natural log and the e to the x derivatives. I don't have these, and I do work these out on first principles. But take a look at this and compare it to if I just say, well, the derivative of e to the u. Like if I said d by dx of e to the u, what's that equal to? It's e to the u times du by dx, right? Now I'm just going to get rid of that. A memory. Like you do have this memorized, right? The derivative of this function is the function e to the whatever times the derivative of the inside. How is this pretty much the same, similar? Well, it's still, if this is 2 to the u, you'd write down 2 to the u and do the derivative of the inside. But because it's not e as its base, do the natural log of that base. So it isn't that difficult to memorize that. But it doesn't come up enough that I'd say you must memorize it. But you must know a thing or two about logs. Now, thinking of the derivative of a natural log expression, right? Isn't it almost the same? Natural log, if this was ln, right, of u, you'd say, well, it's 1 over u, then the derivative of the inside. But now you think, because the base doesn't match, you also have to divide by the natural log of the base. So you can memorize these. I'm just not saying it doesn't pay off huge dividends, but be prepared, you can come across it. Okay, let's go with this one now. I'm going to rewrite this expression here, because as soon as I see x to the power of 1/2, what do you think? It's a log. Swing it out front, right? So this y is really equal to 1/2 log base 5 of x. Now that makes it way easier, because it's 1/2 times whatever derivative you get now, right? Now, that 1/2 is just a multiplier. I'm not doing any calculus on it. It's a constant. But what's the derivative of the log base 5 of x? Well, I'm looking up here. Like I said, well, log base 5, it's still 1 over whatever you have inside the log, so 1 over x. And the base is a mismatch, it's base 5, this log, so I'm going to go natural log of 5. What's the derivative, du by dx? Derivative of the inside of the log expression? It's 1, because it's just plain old x. If it was x squared, it'd be 2x, and so on, right? This is done. So it's not a difficult formula to apply. One last thing. Sometimes the okay, wait, question, sorry. No? Okay. Sometimes the properties of logarithms can be used to simplify differentiation, even if the logs must be introduced as a step in the process. Oh, goodness, look at this one. The process of introducing logarithms before differentiation is called logarithmic differentiation. Okay. Well, let's just have some fun with logs, guys. So if I'm supposed to do the derivative of this expression here, what's my grief here? Yeah, it's because if I had cos of 30, that'd be just fine. But this is, you've got an x expression in the exponent. You got to hatch it out of there. I wouldn't do the derivative of this, man, because I've got to do work on this here. How do I get that down? Natural log of both sides. This is, you shouldn't use the regular log. You could, but then you're introducing, you got to use that other formula that's bigger, clunkier. So do the natural log of both sides. We sort of did this earlier. So the natural log of the y expression is equal to the natural log of, I'm leaving a space here because you know what I'm going to do, of x to the, pausing there, cosine of x. But I'm not going to write that. Maybe you didn't. I'm going to say, well, why would I do that? That's a stupid thing to do. There you go. The cos of x times the natural log of x, right? Dig it? Brothers and sisters? Okay. Now do your differentiation, both sides. You don't literally have to write d by dy or d by dx, I mean. Just do it. It's implicit differentiation that we're doing, right? So this first bit, natural log's derivative is 1 over, and because there's no squares on the y or anything like that, it's just 1 over y. Mismatch, so dy by dx. I don't know why I went lower on this, but whatever I did. Equals. What kind of rule do I have to use here? Because it's something times something, product rule. Derivative of the cosine function is negative sign. Don't touch the next thing. Plus, the first thing left alone. I didn't actually need the brackets around the negative sign thing, just to set it off. Derivative of the natural log expression, 1 over x. So I can write it like this. I could have written cos of x over x, whatever. I have I solved for dy by dx? No. So what do I got to do?
Multiply by y, which is cos x.
Hey, you got it. Yeah. So I'm going to multiply that y up here, but I'm not going to write it as y. I'm going to sub back in. It's clear what. It isn't just cos of x. It's the whole, y is this. The whole thing, right? X. Where was it? Okay. So I'm going to just write that in front. X, cosine of x. I don't need you to simplify any further than this. I don't know why I use square brackets. But if I started with square, I'll end with square. That's good enough. Now, the other questions can be done too now. And just a second here.